Download this code from codegive.com, link in the description below. Don't make these calculate function mistakes. With code examples. The calculate function is a ubiquitous pattern in programming, used for performing calculations, data transformations, and any operation that transforms input into output. However, a poorly designed or implemented calculate function can become a source of bugs, performance bottlenecks, and maintainability nightmares. This tutorial outlines common mistakes made when writing calculate functions and provides practical advice with code examples to avoid them. 1. Ignoring edge cases and input validation. This is probably the most critical mistake. A robust calculate function must handle unexpected or invalid inputs gracefully. Failing to do so can lead to incorrect results, exceptions, program crashes, or even security vulnerabilities. Mistake assuming inputs are always valid. Code example, incorrect. Solution implement input validation and handle edge cases. Code example, corrected. Key improvements type checking using isInstance, to ensure that the inputs are of the expected data types, int or float. Value range checks verifying that the price is non-negative and the discount percentage is within a valid range, 0 to 100. Exception handling using raise to signal errors using appropriate exception types, type error, value error. The calling code can then handle these exceptions gracefully. Considerations for input validation data type ensure the input is of the correct type, example integer, float, string, list. Value range check if the input falls within a permissible range, example age between 0 and 120, temperature between -273.15 and infinity. Format verify that the input matches a specific format, example email address, phone number. Null/empty values handle situations where the input might be none, null, or an empty string. Sanitization if the input comes from an external source, example user input, sanitize it to prevent injection attacks or other security issues. 2. Ignoring potential arithmetic errors, division by zero, overflow. Arithmetic operations can lead to unexpected errors if you're not careful. Division by zero is a classic example, and integer overflow, in languages with fixed size integers, can also cause problems. Mistake assuming division will always be valid. Code example, incorrect. Solution check for division by zero and handle it gracefully. Code example, corrected. Considerations for arithmetic errors division by zero always check if the divisor is 0 before performing division. Overflow/underflow be aware of the limitations of integer data types, especially in languages like C/C++. Consider using larger data types or libraries for arbitrary precision arithmetic if necessary. Floating point precision understand that floating point numbers have limited precision. Avoid comparing floating point numbers directly for equality. Use a tolerance, epsilon, for comparisons. Nan, not a number, and infinity be prepared to handle nan and infinity values, which can result from certain mathematical operations. 3. Lack of clarity and documentation. A calculate function should be easy to understand and use. Lack of clear documentation and meaningful variable names makes it difficult to maintain and debug. Mistake writing cryptic code with no documentation. Code example, incorrect. Solution use descriptive variable names, add comments to explain the logic, and write a comprehensive doc string. Code example, corrected. Key improvements asterisk. Asterisk descriptive variable names asterisk operand 1, operand 2, operation underscore code are much clearer than A, B, C. Asterisk doc string asterisk the doc string explains the purpose of the function, its arguments, and its return value. It also specifies how different operation underscore code values affect the behavior. Asterisk comments asterisk the comment clarifies the else branch's purpose. Best practices for documentation asterisk. Asterisk doc strings asterisk use doc strings, triple quotes in Python, to document your functions and classes. Asterisk type hints asterisk use type hints, available in Python 3.5+, to specify the expected data types of arguments and return values. This helps with code readability and static analysis. Asterisk clear variable names asterisk choose variable names that accurately reflect the purpose of the variable. Asterisk comments asterisk use comments to explain complex logic or non-obvious parts of your code. 4. Ignoring performance considerations. In performance-critical applications, the calculate function can become a bottleneck if it's not optimized. Avoid unnecessary computations, memory allocations, and inefficient algorithms. Mistake asterisk using a naive algorithm when a more efficient one exists. Code example, inefficient. Solution asterisk use a more efficient algorithm, example checking only up to the square root of the number. Code example, efficient. Key improvements asterisk. Asterisk reduced iterations asterisk the efficient version only iterates up to the square root of the number. This significantly reduces the number of iterations for large numbers. Performance optimization techniques asterisk. Asterisk algorithm selection asterisk choose the most efficient algorithm for the task. Asterisk memoization / caching asterisk store the results of expensive calculations and reuse them when the same inputs are encountered again. Asterisk loop optimization asterisk reduce the number of iterations in loops, avoid unnecessary computations inside loops, and consider using vectorized operations, example NumPy arrays, for numerical calculations. Asterisk data structures asterisk choose the appropriate data structure for the task, example dictionaries for fast lookups, sets for checking membership. Asterisk profiling asterisk use profiling tools to identify performance bottlenecks in your code. 5. Lack of testability. A calculate function should be easy to test. Avoid tightly coupling it to external dependencies, and ensure that it's deterministic, produces the same output for the same input. Mistake asterisk tightly coupling the function to external resources, making testing difficult. Code example, difficult to test. Solution asterisk decouple the function from the file system by passing in the file content directly, allowing for easier mocking and testing. Code example, easier to test. Key improvements asterisk. Asterisk decoupling asterisk the calculate underscore string underscore length function is decoupled from the file system. It only operates on the input string, making it easy to test with different inputs. Testability principles asterisk. Asterisk dependency injection asterisk pass dependencies into the function as arguments instead of creating them inside the function. This allows you to mock or stub the dependencies during testing. Asterisk deterministic behavior asterisk ensure that the function produces the same output for the same input. Avoid using global variables, random numbers, or other sources of non-deterministic behavior. Asterisk unit tests asterisk write unit tests to verify that the function works correctly for different inputs and edge cases. Use a unit testing framework, example ptest, unitest, to automate the testing process. Code coverage measure the code coverage of your tests to ensure that all parts of the function are being tested. 6. Ignoring error handling, general. While input validation is part of error handling, it's also important to handle potential errors that may occur during the calculation itself. Catch exceptions, log errors, and provide informative error messages. Mistake * letting exceptions propagate silently. Code example, incorrect. Solution * use try, except blocks to catch exceptions and handle them appropriately. Code example, corrected. Key improvements * try, except blocks * the code is wrapped in a try, except block to catch potential exceptions. Specific exception handling * the code handles zero division error and type error exceptions specifically. Logging * the code logs errors using the logging module. This allows you to track errors and debug your code more effectively. Note that logging.exception logs the entire trace back, which is crucial for diagnosing unexpected errors. Error handling strategy * the function returns none to indicate that an error occurred. Alternatively, you could raise a custom exception or return a default value. Best practices for error handling *. Be specific * catch specific exception types whenever possible. This allows you to handle different types of errors in different ways. Log errors log errors to a file or database. This allows you to track errors and debug your code more effectively. Provide informative error messages include relevant information in your error messages, example the input values that caused the error. Handle errors gracefully avoid crashing the program due to errors. Provide a way for the user to recover from the error or to report it to the developer. Rethrow exceptions sparingly only rethrow exceptions if you need to perform some additional processing before the exception is handled by a higher level handler. 7. Unnecessary side effects. A calculate function should ideally be a pure function. Given the same input, it should always produce the same output and have no side effects, example modifying global variables, writing to files, printing to the console. Side effects make functions harder to test, debug, and reason about. Mistake * modifying a global variable inside the calculate function. Code example, incorrect. Solution * avoid modifying global variables. If you need to update a counter, pass it in as an argument and return the updated value. Code example, corrected. Key improvements *. No side effects the calculate _square function only calculates the square of the input and returns the result. It doesn't modify any global variables. The counter management is handled outside the function. Benefits of pure functions *. Testability * pure functions are easy to test because you only need to provide the inputs and verify the output. Debuggability * pure functions are easier to debug because they don't have any side effects that could affect the program's state. Composability * pure functions can be easily composed to create more complex functions. Concurrency * pure functions are safe to use in concurrent environments because they don't modify shared state. In summary, avoiding these mistakes will help you create calculate functions that are reliable, efficient, maintainable, and testable. Remember to prioritize input validation, error handling, performance considerations, and testability when designing and implementing your calculate functions. Clear documentation and the avoidance of side effects are also crucial for writing high-quality code. By following these guidelines, you'll significantly improve the quality of your programs and reduce the likelihood of bugs and performance issues.